Hi, everyone. So next, we would like to define the annuity due. So annuity due is a similar cash flow as annuity immediate, but the slight difference in timing of payments. So annuity due is defined as this. So again, we have time point 1 to n. And okay, so this. But the cash flow is slightly different because it starts at time 0. So that means the $1 at time 0 and $1 at time 1, $1 at time 2, up to time n-1. So just the payments are 1 year earlier. So this is the definition of annuity due. So what is the present value of annuity due? So that is just slight different. That has slight difference from the A right angle n. So we write the A double dot angle right angle n. So the definition of A double dot the right angle n is the present value of this annuity due. So the definition is present value of annuity due of n years. And what's the how to calculate this? So this is equal to, okay, so at first the present value of 1, so that is obviously 1, and the present value of the $1 at time 1, this is v, and the v square, and so on. And finally, we end at v to the power n-1 because our last payment is $1 at n-1. So actually, this is just the A right angle n, the divided by v. Right. So this is actually by using the formula for the summation of the geometric sequence, this becomes this. And 1 minus v is defined as d. So if we use d, then we can write this as 1 minus v to the power n over d. Yeah, so this is the formula for A double dot right angle n. And the next, we similarly define the accumulated value of this annuity due. And if we think about the accumulated value, that is 1 plus I to the nth power. So this times the so A double dot right angle n times 1 plus I to the nth power is the S double dot right angle n. So the definition of S double dot right angle n is the present the accumulated value of annuity due, and this is 1 plus I to the nth power times A double dot right angle n. So this is, okay, so 1 plus I to the nth power, and the 1 plus I to the nth power and the v to the nth power cancels. So these cancel, so minus 1 over d. Yeah, so remember that the d is 1 minus v, or 1 minus v is 1 plus 1 over, sorry, the 1 minus 1 plus 1 over 1 plus I. So this is I over 1 plus I. And this is the formula for S double dot n. Okay, so now that we define the A right angle n, the S right angle n and A double dot angle n and S double dot angle n. But basically, these are the same thing. So just the value at some point of this n times the $1 payment, the $1 payment for n times. So just we are seeing this cash flow at a different time point. So property on A right angle n, S right angle n, and the A double dot angle n and S double dot angle n. So think about the time diagram. So 0, 1, 2, 3. Okay, so maybe n minus 1, n. So we have n payments. So okay, so think about just the annuity immediate case. Then we have n payment. And if we evaluate at time 0, that is A right angle n, evaluated at time 1, actually this becomes A double dot right angle n. So this is equal. And if evaluated at n minus 1, n minus 1 isn't really important. At n, if evaluate at n, that is S right angle n, S right angle n, and if evaluated at n plus 1, this is S right angle. Sorry. This is S right angle n, and this is S double dot right angle n. So just the point of evaluation is different. So we have this value of the same cash flow at different time point. So we have, if we multiply 1 plus I here, we multiply 1 plus I here. Okay, so that means the A right angle n and the A double dot angle n. Okay, so this is 1 plus I times larger. And if we think about an times 1 plus I to the power n, then this becomes a S right angle n. And further, we multiply 1 plus I, that becomes S double dot angle n. So this is the relationship between these 4 quantities.